The night sky has always been a canvas of dreams, a vast tapestry of stars that whispers questions older than humanity itself. What lies beyond the veil of darkness? Are we alone in this cosmic sea, or are there others out there, gazing back at us with the same curiosity, the same longing? For centuries we've scanned the heavens, our telescopes like eager eyes, searching for a sign, a flicker, a pulse, a whisper that might prove we're not alone. And now, in the quiet hum of the cosmos, something extraordinary has emerged. A single image from the James Webb Space Telescope, a fleeting glimpse into the depths of space, has ignited a firestorm of wonder and debate. Renowned physicist Brian Cox, a man whose voice carries the weight of both science and awe, has called this image a potential turning point in human history. This, he says softly, his eyes alight with possibility, might be proof we're not alone. What is it about this one photograph, this sliver of light from a galaxy cluster billions of years away, that has astronomers holding their breath? What secrets does it hold that could unravel everything we thought we knew about the universe? Let's step into this mystery together, not as detached observers, but as explorers standing on the edge of the unknown, hearts racing with the thrill of discovery. The James Webb Space Telescope, humanity's most powerful eye into the cosmos, has given us a window into the universe that no one could have imagined. Its golden mirrors, suspended in the cold void of space, capture light that has traveled for billions of years, carrying stories from the dawn of time. One of its deep field images, a snapshot of the galaxy cluster SMACS 0723, reveals a breathtaking vista. Thousands of galaxies, each a swirling city of stars, crammed into a patch of sky no larger than a grain of sand held at arm's length. It's a humbling reminder of our place in the universe, a testament to the sheer scale of existence. But within this celestial masterpiece, something strange caught the attention of the world's sharpest minds. A section of this image was withheld from the public for 8 long weeks, locked away under the vague explanation of data calibration issues. 8 weeks is an eternity in the fast-paced world of astronomy, where discoveries are shared with the urgency of a heartbeat. Why the delay? What was NASA hiding? When the segment was finally released, it revealed a mid-infrared anomaly, a faint, ghostly signal that didn't behave like anything astronomers had seen before. Dr. Eleni Vasquez, a NASA subcontractor and one of the first to study this anomaly, described it with a tremor in her voice. It was unlike anything I'd ever encountered. The infrared signature showed patterns that simply shouldn't exist. This wasn't just a smudge of light or a quirk of cosmic dust. The anomaly pulsed with a rhythm, a structured periodicity that seemed almost deliberate, like the ticking of a cosmic clock. Scientists pored over the spectral data, their computers humming through the night, and what they found sent a shiver through the astronomical community. Hidden within the light were non-random pulse gaps, regular intervals that defied the chaos of natural cosmic phenomena. Fourier transformation, a mathematical tool used to uncover patterns in complex signals, revealed a cadence, a rhythm, that felt eerily out of place in the random dance of stars and gas clouds. Brian Cox, ever the voice of cautious wonder, weighed in with a statement that carried the weight of a revelation. This kind of structured periodicity isn't seen in natural sources unless there's a rotation or an artificial gating mechanism. His words hung in the air, heavy with implication. In astronomy, regular patterns usually come from spinning objects like pulsars, neutron stars that sweep their radiation beams across the sky like lighthouses. But this wasn't a pulsar. It didn't match any known cosmic object. It was something else entirely, something that whispered of intent, of design. The anomaly's strangeness deepened when researchers noticed its thermal signature, a series of concentric heat rings, like ripples frozen in time, radiating outward from a central point. These rings didn't match the infrared profiles of stars, nebulae, or galactic collisions. They were too precise, too ordered. Theoretical physicists began to whisper about a concept straight out of science fiction. A matryoshka brain, a megastructure of nested shells built around a star, each layer capturing energy and radiating waste heat in a pattern that mirrors what the telescope had found. Named after Russian nesting dolls, this hypothetical construct isn't just about harvesting energy like a Dyson sphere. It's about computing power on an unimaginable scale, potentially housing an entire digital civilization. The idea is staggering, almost too vast to grasp. Could we have stumbled upon the footprint of a civilization so advanced that it builds not just machines, but entire worlds within worlds? The thought sends a chill down the spine, not of fear, but of awe. What kind of beings could create such a thing? And why would they hide it in the vastness of space, where only a telescope as powerful as Webb could catch a glimpse? But the mystery doesn't end there. In a twist that feels like the universe itself is playing tricks on us, another piece of evidence emerged from an entirely different corner of the cosmos. Voyager 2, NASA's aging explorer drifting at the edge of our solar system, billions of kilometers away, recorded a subtle glitch in its star tracker system. This instrument, designed to navigate by locking onto distant stars, registered a tiny deviation, so small it could have been dismissed as noise. But when engineers traced the coordinates of this glitch, their jaws dropped. The deviation pointed to the exact same region of space as the JWST anomaly. Two instruments, separated by unimaginable distances, operating on entirely different principles, had both caught a whisper from the same cosmic address. A JPL analyst, speaking anonymously, put it bluntly, "The probability of this being random is vanishingly small. The coincidence is almost too perfect, too haunting. It's as if the universe is nudging us, urging us to look closer, to question everything we thought we knew." This discovery comes at a time when the James Webb Telescope is already rewriting our understanding of the cosmos. Just months ago, it turned its gaze on K218b, an exoplanet 124 light-years away, orbiting in the habitable zone of its star. The telescope detected traces of methane and carbon dioxide in its atmosphere, hinting at the presence of liquid water, an ocean world perhaps teeming with possibilities. But the real bombshell was the detection of dimethyl sulfide, a molecule produced almost exclusively by living organisms on Earth. The signal isn't conclusive, but it's strong enough to make scientists sit up and take notice. Within months, the same telescope that may have glimpsed a megastructure in the depths of space has also found a potential biosignature on a distant world. The universe, it seems, is no longer content to keep its secrets. It's shouting them across the light years, daring us to listen. As we stand on the brink of this cosmic revelation, the question looms larger than ever. What does it mean to find something like this? The anomaly, with its rhythmic pulses and nested heat rings, doesn't just challenge our science, it challenges our imagination. It forces us to confront the possibility that we're not just observers of the universe, but participants in a story far grander than we ever dreamed. If this is the work of an advanced civilization, what are they like? Are they watching us, hidden in the shadows of the cosmic forest, silent for reasons we can't yet fathom? Or is this anomaly a relic, a forgotten monument to a species that once reached for the stars and then vanished into the void? The answers are out there, encoded in the light that has traveled billions of years to reach us. And as we peer into that light, we can't help but feel the weight of our own place in the cosmos. A small, curious species standing at the edge of a discovery that could change everything. The universe has a way of humbling us, of reminding us how small we are against its infinite expanse, yet how boundless our curiosity can be. The anomaly in the James Webb Space Telescope's Deep Field image, a faint, rhythmic pulse of light from a galaxy cluster billions of years away, has stirred something deep within us. It's not just the data, the infrared signatures, or the concentric heat rings that defy explanation. It's the feeling they evoke, a mixture of awe and unease, like standing at the edge of a cliff and peering into a void that might be staring back. What if this signal, this strange whisper from the cosmos, wasn't meant for us at all? What if we've stumbled upon something we were never supposed to see, a fleeting glimpse of a civilization so advanced it hides in plain sight, cloaked in the silence of the stars? As we dive deeper into this mystery, the questions grow sharper. the possibilities more breathtaking. The anomaly's structured periodicity, its thermal rings, and its eerie alignment with a glitch in Voyager 2's star tracker system have already shaken the scientific community. But there's more to this story. Layers of strangeness that pull us further into the unknown, where the line between science and wonder blurs into something almost mythical. Consider the dust rings surrounding the anomaly, a delicate halo of particles that should have been unremarkable, just another cosmic cloud scattered by the whims of gravity. But when astronomers zoomed in, enhancing the image to scales finer than ever before, they found something that stopped them cold. The dust didn't drift in the chaotic swirls typical of stellar nurseries or galactic collisions. Instead, it arranged itself in a fractal pattern, a self-repeating structure that echoed across multiple scales, like a cosmic mandala. These weren't the random clumps of interstellar debris we're used to seeing. They bore an uncanny resemblance to patterns we associate with life on Earth, patterns like the spiral of a nautilus shell, the branching of a fern, or the Fibonacci sequence etched into a sunflower's seeds. An imaging specialist, her voice tinged with disbelief, described the discovery. We kept seeing the same geometric ratios, repeating over and over, as if the dust was following a mathematical blueprint. This wasn't the work of gravity alone. It felt designed, intentional, like a signature written in the language of the universe itself. The implications of this fractal pattern are staggering. On Earth, such structures emerge from growth processes, from the way living systems organize themselves to maximize efficiency. Think of a tree's branches spreading to capture sunlight, or the spiral of a galaxy, echoing the same mathematical elegance on a cosmic scale. But this dust ring, billions of light years away, wasn't just beautiful. It was precise, almost too perfect. Astrophysicists called in biologists to examine the data, and their reaction was nothing short of startling. One biologist, peering at the enhanced images, shook her head and said, "This symmetry is more like biology than astrophysics. It's the kind of pattern we see in living systems, not in the random churn of cosmic dust." Could this be a galactic-scale biosignature, evidence of life operating on a scale so vast it defies comprehension? The idea stretches the mind to its limits, blurring the boundary between technology and biology. What if this anomaly isn't just a machine, but a living system, an extension of life itself, woven into the fabric of the cosmos? This discovery brings us face to face with a concept that feels like it belongs in a science fiction novel, yet is grounded in the cold logic of theoretical physics. The dark forest hypothesis. Popularized by Liu Cixin, this chilling idea suggests that the universe is like a vast, shadowy forest, where every civilization is a hunter, moving silently to avoid detection. In this cosmic game of survival, broadcasting your existence is tantamount to inviting destruction. Advanced civilizations, the theory goes, might choose to remain hidden, cloaking their presence to avoid attracting predators. Astrobiologist Dr. Kamal Reyes put it hauntingly, "It's like catching the glow of a submarine's periscope in the dark. It's not a message, it's a mistake." What if the anomaly we've detected is just that? A momentary slip, a technological leak from a civilization that has spent millennia perfecting its invisibility? The thought is both thrilling and terrifying. We might have glimpsed the equivalent of a cosmic whisper, a signal that was never meant to reach our curious eyes. This idea of a hidden cosmos forces us to rethink what we're looking for when we search for extraterrestrial life. For decades, programs like SETI have scanned the skies for radio signals, expecting a deliberate hello from another world. But what if advanced civilizations don't use radio at all? What if they communicate in ways we're only beginning to understand, using parts of the electromagnetic spectrum, like the mid-infrared, that we've only recently gained the tools to explore? The James Webb Space Telescope, with its unparalleled ability to peer into the infrared, has opened a new chapter in this search. It's not just seeing farther than ever before, it's seeing differently, catching signals that might have been invisible to older telescopes. Perhaps the answer to the Fermi paradox, why we haven't found alien life despite the universe's vastness, isn't that we're alone, but that we've been looking in the wrong places, listening at the wrong frequencies. The anomaly, with its rhythmic pulses and fractal dust patterns, feels like a clue, a breadcrumb leading us toward a truth we're only beginning to grasp. Then there's the matter of the light itself, the most baffling piece of this cosmic puzzle. When astronomers analyze the light from the anomaly's region, they notice something impossible. A 12-second delay in its arrival, defying everything we know about how light travels through space. Light, the cosmic constant, the unwavering messenger of the universe, was behaving as if it had taken a detour. At first, researchers thought it was a glitch, an error in the telescope's instruments. But after exhaustive checks, the delay was confirmed to be real. One scientist, his voice heavy with the weight of the discovery, said, "The light is arriving later than it should, and we don't know why." This anomaly suggests two possibilities, each more astonishing than the last. The first is an extreme form of gravitational lensing, where massive objects bend spacetime, altering the path of light. But the precision required for this delay is far beyond what any natural phenomenon could produce. The second possibility ventures into territory that makes even the boldest scientists pause: engineered time dilation. Could a civilization so advanced have mastered the manipulation of space-time itself, creating pockets where time flows differently, like a controlled version of the warped reality near a black hole? This idea, as wild as it sounds, isn't entirely new. Theoretical physicists have long speculated about the capabilities of a Type 3 civilization on the Kardashev scale, a species that harnesses the energy of an entire galaxy. Such a civilization could, in theory, bend the laws of physics to their will, creating structures and effects that seem like magic to us. The anomaly's concentric heat rings, its fractal dust patterns, and now this inexplicable light delay all point to something that doesn't fit within our current understanding of the universe. It's as if we've caught a glimpse of a machine or a living system so vast and complex that it operates on principles we can't yet comprehend. Brian Cox, ever the voice of reason, puts it in perspective. If we ever found a structure like this, it wouldn't be horrendously surprising. Given the age and vastness of the universe, it's almost inevitable. His words carry a quiet excitement, a reminder that the universe is old enough, big enough, for wonders we can scarcely imagine. As we grapple with these possibilities, the coincidence with Voyager 2's glitch looms larger. Two independent instruments, one a cutting-edge telescope orbiting the sun, the other a decades-old spacecraft drifting at the edge of our solar system, both pointing to the same patch of sky. It's a connection that feels almost orchestrated, as if the universe is urging us to pay attention. NASA has remained tight-lipped, initiating a technical review behind closed doors, while observatories around the world have quietly redirected their telescopes to this region of space. The scientific community is proceeding with caution, aware that extraordinary claims require extraordinary evidence. But the sense of anticipation is palpable. We're not just looking at data anymore. We're standing at the threshold of a discovery that could redefine our place in the cosmos. The anomaly isn't just a signal, it's a story, one that's been traveling across billions of years to reach us. And as we listen, we can't help but wonder, what will it tell us about who we are and who else might be out there, waiting in the dark? The stars have always called to us, their distant light a siren song of mystery and possibility. Now, as we stand on the edge of a discovery that could rewrite our place in the cosmos, the anomaly in the James Webb Space Telescope's image feels like a message from the universe itself. Its rhythmic pulses, fractal dust patterns, and inexplicable 12-second light delay, coupled with Voyager 2's eerie glitch pointing to the same cosmic address, have left us breathless, teetering between wonder and uncertainty. Is this the footprint of a civilization so advanced it bends time and space, or a natural phenomenon we've yet to understand? The question hangs heavy, like the silence before a storm. Brian Cox's voice echoes in our minds. If this is real, it would change everything. The concentric heat rings, resembling a matryoshka brain, suggest a structure of unimaginable scale, perhaps a digital civilization humming in the void. The fractal patterns in the dust, mimicking life's own blueprints, blur the line between machine and organism. And the light delay, defying physics, hints at a mastery of reality we can barely fathom. Yet this anomaly isn't alone in stirring our imagination. The James Webb's discovery of dimethyl sulfide on K218b, a potential biosignature from an ocean world 124 light-years away, suggests life might not just exist but thrive across the universe, from simple organisms to builders of cosmic megastructures. These findings converging in a single moment feel like the universe whispering, "You're not alone." But the silence of the cosmos, as the dark forest hypothesis warns, might mean others are hiding, wary of unseen dangers. Our own Voyager probes, carrying golden records of Earth's songs and greetings, drift as bold messages in a bottle, yet we've heard no reply. The Fermi paradox looms. With billions of Earth-like planets, where is everybody? Perhaps they've been there all along, visible only now through Webb's infrared gaze, in wavelengths we're just learning to see. NASA's quiet redirection of telescopes and hushed technical reviews signal the weight of this moment. Scientists tread carefully, knowing extraordinary claims demand extraordinary proof. But the data, those pulses, those rings, that delay, forms a pattern too compelling to dismiss. Cox's call for open-minded rigor resonates. This isn't nonsense to shrug off. It's a mystery to chase with every tool we have. The universe, once thought vast and empty, now feels alive with possibility, a place where life and technology might weave together in ways we can't yet comprehend. As we peer into this cosmic mirror, we see not just stars but ourselves, curious, fragile, and daring to dream. This anomaly, whether a relic of a lost civilization or a natural enigma, reminds us that our search for answers is also a search for meaning. The truth, shimmering just beyond our reach, waits in the light of distant stars, urging us to keep looking, to keep asking. Who else is out there, and what stories do they hold?